Hello viewers and my dear students, welcome to session 2, problem 3 on analysis of beams. Here I was showing a demo on simply supported beam with partially applied uniformly distributed transverse load using Ansys Release 14 of Mechanical APDL to obtain bending moment and shear force diagrams. This I've already started. In the previous session, I've shown you how exactly to do the by theoretical methods, how to get the reactions RA and RC and all that. I've shown RA will be 32,000 newtons, RC will be 16,000 newtons. In the same way, I've shown you how exactly to get shear force diagrams and how exactly to get bending moment diagrams, and more importantly, I've even shown wherever shear force is 0, that is at a distance of x from left support, there you will have maximum bending moment. That calculation also I told you, that is 42,670 approximately Newton meter. This is the thing. This and all that we have already done, and in fact we have even started using mechanical APDL, Ansys also. We have created key points. Key point 1 is 0, 0, 0. Key point 2 is 4, 0, 0, 4 meters 0, 0. Key point 3 is 6, 0, 0. Okay, now I create lines, straight line. I'll connect this and this. I'll connect this and this. Okay, and say okay. Okay, then I'll go for meshing, mesh attributes, picked lines. This and this I'll pick and say okay. Okay, now there is only one material, real constant already in the section I've named. Just say okay. Okay, don't worry about pick orientation key point right now. Don't touch this. Okay, just say okay. Okay, then size controls you go, manual size you go, lines you go, picked lines you go, click on this and click on this. Carefully you see, I'll make it 50 divisions, because I want the bending moment diagram to be written properly. Otherwise, if you do just 4 or 5 elements, the bending moment diagram will not look better. More the number of elements, more better will be the bending moment diagram. Okay, that is why I made 50. Okay, I just say okay. Now you see, this is divided into 50, this is 50. Okay, then if you do this, mesh, lines, if you do pick all or click on both the lines, you are having 100 elements. Okay, list you see, elements, nodes and attributes. If you see, if you say 100 elements, you would have got, correct? No? This is elements, 100 elements you have got. Okay, now you see here, once you do this, now we'll start loading. That is solution phase you go, loads, define loads, apply, structural, displacement, on key points. You click on this and click on this where it is simply supported. Okay, just say okay. And UX, UI, UZ, rotation X, rotation Y, simply supported. No, you make it 0. Rotation Z, let it be there, because you'll have to find the slope and all that. Okay, the bending shape will be clear. That is why rotation Z, you make it open. All other things you arrest. Say okay. Okay, then you be careful now. Now you see here, plot controls, numbering. Okay, you see here, element numbers. If I do this, if I say on, you see here, element numbers is on now. Okay, carefully you see. Here 42, 43, 44, 49, up to 50 and all that you have. Okay, this is element number. That is 50 elements here and 50 elements here also. You can see here. Okay, 51 up to totally 100 elements you'll have. Okay. Now what I'll do is, pressure on beams is only up to 50 elements. Only partially applied partial, that is UDL. That is why what I'll do, pressure on beams, you take box here. Okay, box you take. Just see, because you have to be very careful here. You apply up to here. Okay, then you go for single, okay, because we don't know where exactly is 50, that is why you go to single. Now you enlarge the area, zoom model. Okay, now 48 is there, 49, 50 you go, okay, then 51 and all that, don't worry, you cancel off. Okay, up to 50 you do carefully, you do it this way. Okay, then you say fit view. Okay, then say okay, and compulsorily load key, no, you take it as 2, otherwise you will, the load will be acting in the other direction, horizontal direction. Load key, you change it to 2. Pressure value is 12,000 newtons, no, 12,000 newton at I and J. It is uniformly distributed load. It is 12,000 newton per meter. Okay, 12,000 you give here. Just say okay. Now it is proper. Okay, now it is proper. I'll just say plot controls, numbering, element numbers. I'll make it on. I'll make it off so that it will not confuse her. Now it is perfect. It is okay. Now it is, you are fixed here, and UDL has been applied here. In that way, it is proper in all from all angles. See here. Here you have arrested all degrees of freedom. Here you have arrested all degrees of freedom, and you have applied partially up to here. It is proper till now. Now once you do this, now you go for the, we are in the solution phase. Solution, solve, current LS you do. Say okay. Solution is done, you get okay, say file, close you do. Now what I suggest, no, once you do this, the solution phase is over. Now you are going for general post-processing phase. First you check what you've done is correct or not immediately. The first one, list results, reaction solution, you see. Here only you will know whether you've done correctly or not. You see here. First is, the first node is 32,000, 16,000, 32,000 F5. All other things are negligible. This is Fx, Fy, Fz. This is 0, this is 0. Fy 32,000 and 16,000 is the thing what you have already got. Okay. Now see here, 32,000 and 16,000. At this 32,000, at this 16,000 is the thing what you have got. That is perfectly okay. That means what you've done till now is perfect. Okay. Okay. Now this is the thing. Next, what you do is you go for element table. Element table, define table, add. Okay. By sequence number. Now, as you know, SMISC 6 apply. SMISC 19. SMISC 6 and 19 combination will give you shear force diagram. In the same way, by sequence number, SMISC 3, SMISC 16. Please check. This is SMISC 6 and 19 will give you the shear force diagram. SMISC 3 and 16 will give the bending moment diagram. You just say close. You do this. Okay. Now you have to view carefully. Now general post process, plot results you go. Now you see here. Here contour plot, line element results, and as I said, you go for 3 and 16. Just say okay. Okay. 3 and 16 will give you the bending moment diagram. As you see here, the maximum bending moment is 42,656. No, 42,656. Okay, is the maximum bending moment. Red you see 42,656 somewhere here. Okay, up till here it is a straight line and all that I told you. After that the curve begins here and it is maximum moment 42,656, and we have done it theoretically also. Okay, 42,656, it is 670 here. Okay, 42,670 here. It is almost a correct value now. Okay, 42,000. Next, line element results. 6 and 19 you take. 6 and 19 will give you shear force diagram. You just see this is red 16,000 and this is 31,520. That means here actually it should be 32,000. If you had done more number of elements, it would have reached, let us say 100 elements here, 100 elements here, it would have definitely been 32,000 only, minus 32,000. Now since we had done 50 elements, it is almost okay. It is instead of 32,000 minus 32,000, it is minus 31,520 and it is 16,000 here. This is correct. This also you just verify. You see 16,000 here and minus 32,000 here. This is also correct. Okay. Did you follow? Okay. In that way, your bending moment diagram is proper. Shear force diagram is proper. I'll immediately tell again. See here, 3 and 16 is one very important thing. Bending moment diagram is perfect. Immediately this has to be recorded in your record books or even the exam and all that. You have to take the printout of it by writing meta file, invert white and black, and take the printout in. This black will become white, invert white and black. This will be anyway in paint. You just take the printout of it and give it. Or you make a selected only this amount, that is only the bending moment plot you can copy it and paste it in Word, and simultaneously bending moment diagram, shear force diagram, everything you can give it in one sheet only. Okay, this line element results. In the same way, 6 and 19 will give the shear force diagram. This also plot controls, write meta file, invert white and black. In that way, you do this also is a very important file. Bending moment diagram file, shear force diagram file. You have to give it, you have to show it to the examiner, or if you are writing it in the record, you can write the same thing using your pencil scale and all that. You show it and show this as minus 31,520, but actually it should be minus 32,000. This is 16,000. You hatch the area in the same way. It is even better, and clearly write it as it is a shear force diagram. Okay, this also has to be recorded. And importantly, I have told you under list results, reaction solution only, you will know what exactly is the thing. Okay, this also has to be recorded. 32,000 and 16,000. At node 1 it is 32,000. At node 52 it is 16,000. Node 52 is the last node. Okay, if you can see that plot elements and plot controls numbering, if you switch on the node numbers on, you will get so many things. No, you enlarge the area. See here, if you enlarge the area, last thing is 52 only. Okay, did you follow? List results, reaction solution, all items if you do, see carefully, first anyway is 32,000, at 52 it is 16,000, exactly matching with our results what we have got using theoretical methods, as I just now told you. Okay, it is theoretical methods what I told you, 32,000 and 16,000. In that way, we have completed the problem on that is partially applied UDL, UDL. Okay. Okay. Thanks, friends, for watching. We have completed this session. We'll start with a new session in the next session. That is bending stress diagram.